So if I were to say something here, I would say that the problems that we're doing today it's more of the same, but these are the hard problems. Okay, these problems are a little bit trickier. This one involves trigonometry, and then the other one, if we get a chance to get to it today, has a bunch of variables involved. So the two problems we're looking at today, these are kind of like the tougher related rate problems. All right, so follow along with me here. We have a 10-foot ladder slides down a wall at a constant rate of 2 feet per second. How fast is the angle of the base of the ladder and the ground changing when the base of the ladder is 6 feet from the wall? All right, so let's get down to business here. So first of all, we have a wall, we have a ladder leaning up against that wall. It's sliding down, so the height is changing, right? The length of the ladder will not be changing, so I use a constant for that. I'll put a 10 there. I would imagine the base is also changing, whatever that is. And then the angle is another, that's the new part for today. The question was, how fast is the angle changing? Okay? All right, so there's my picture, step one. Step two, let's identify what rate I'm trying to find. What rate am I trying to find? Okay, well, they asked us to find how fast the angle is changing. That would be d theta dt, the rate of change of the angle with respect to time. Now, what are the units of d theta dt? Jade, do you want to sit here? That would be radians, is what we measure our angles in calculus. And in the problem, they told us the time that we're looking at is seconds. So that's kind of weird, but that's how we're going to put our units for that. It's radians per second. Okay? Would we expect this to come out to be positive or negative? It's going to be negative. Now let me tell you why. The ladder is sliding down the wall. As this ladder slides down the wall, what happens to that angle? It approaches zero. It's getting smaller and smaller, so it's going to end up being a negative measurement. Okay? Step three, let's identify the rate that they gave us. Now that's a little bit tricky. What it said in the problem is it says the ladder is sliding down the wall at 2 feet per second. So what variable is changing? What variable are they talking about when they say the ladder's sliding down the wall 2 feet per second? That's A. They're talking about the height. It's sliding down the wall, right? You're right. B will change, but the rate that they gave us, it tells us how fast it's sliding down, not across, right? So it's dA dt, and that would be 2 feet per second, kind of. What will it be, though? It's not 2 feet per second. It's negative 2 feet per second because A is doing what? Yeah, the ladder's going down, so A is decreasing, right? And so that's a negative rate. All right, so now here's where the fun stuff comes in. I need to find a formula that connects what two variables? Yes? No, not.
We're looking for the connection between A and theta.
That's what I wanted. Thank you. So we're looking for the thing that connects theta and A. Okay, well, if you got an angle involved, now we're talking SOHCAHTOA. Okay, so I'm going to write this. You don't have to write this, but I'm just going to write this for reference. I need to use what variables? A and theta. So that's 2. But you need 3 to make a trig formula, okay? And the third one you're going to use is the constant number, which is what? Yeah. Okay? So now you have to remember what opposite, adjacent, and hypotenuse are. From this angle, A is the opposite. 10 is the hypotenuse. So that's O and H. The one that has O and H in it is S, which is sine. And here's how you would set this up. You would say sine of theta is equal to opposite over hypotenuse. So once again, you have to use the letter that you want. We want A. This is the big question people have, is in how to set this up. You have to pick the two correct sides. One side you correct has to have the letter in it that you care about. We care about A. The other side has to have the number in it. From there, you have to know if they're opposite, adjacent, hypotenuse, so that you know whether it's sine, cosine, or tangent. Okay, so there's that. All right. Step 5 is to find the derivative. So I'm going to take the derivative of this thing now with respect to time. Now, before I start, I'm going to rewrite a over 10 a little bit so it looks a little bit more familiar. I'm going to write it like this, because now you guys can see it's just a constant times a variable. Okay? So if I take the derivative of sine, that's going to give me cosine. But don't forget, multiply it by that as well. Over here, the derivative of that would just be 1/10, but don't forget to multiply it by the rate, the ADT. All right, so we've crossed hard part number 1. This is hard part number 1. If you don't remember how to set up your trig ratios, this will be kind of a toughie problem for you today, okay? But if you do know how to set them up, that won't stump you. Take your derivative, not too bad. We're about ready to encounter the next hard part. Here we go. I'm looking for d theta dt, which means I need to find two other things in order to get this answer. I need to know what this is. What is dA dt? We have that, right? But I also need to know something else. I need to know what the heck cosine of theta is. Okay? So, let's go ahead and write what we know. I'm going to put some blanks here. This is -2. Okay, we're good there. Now, I just need to figure out what this is. So this is where things get kind of interesting. Well, cosine of theta, come back to step 4, right? Cosine of theta is what over what? B over 10. Now, I want just a number here, though. I don't want any more letters, because remember, at this point in the game, I want to get rid of all letters and have just the one thing that I'm trying to solve for. So I don't want to put a B in there. So what can I put instead?
When we're not looking for a general solution, so we're looking for a specific solution, that is when the bottom of the ladder is 6 feet away from the wall, which is, so just change out B for 6. Yeah.
They told us that in the problem?
Yeah.
There it is. That'll do it. Okay? So that's kind of the tricky part, because that's weird too, right? Usually when we're missing a variable, we come back over here and we plug in a number to find the missing piece. It's not quite how it works here. You set up a new trig ratio to find the trig ratio. Okay? So we end up with 3/5 if you reduce that. And this becomes -1/5. Yep, multiply both sides by the reciprocal. And we have our answer. Those go away. We got -1/3. And that was in radians per second. There it is. So it was all in step 4 is where it gets weird, right? Setting up your formula and also finding the missing piece. All right? So I'm going to let you guys try one of these. Are we good on writing? I can move on. You want to take a picture? You look busy. You okay? Okay. I just didn't want to leave you behind. But if you need me to take a picture, you can. Here you go. You try one. So let's go ahead and do another problem here. These are tough, so don't feel bad. Just kind of think of it as, okay, I'm kind of seeing new things, you know. Not necessarily mastering this stuff right now. We're just kind of exposing new things. All right. This is kind of disappointing. I wonder which one would be easier. Okay. So let's do this one. A water tank has the shape of an inverted cone with base radius 3 and height 9. If water is pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 1 meter deep. Okay. So, what kind of a picture am I going to draw?
A water tank.
An inverted cone that, yes, it is a water tank. Good.
Ice cone.
Yeah. It says this thing has a radius of 3. Is that ever going to change? No. So I'm going to put 3 right there because that's never going to change. Next, it has a height of 9. Is that ever going to change? No. So I'm going to put a 9 right there. If water is pumped into this tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 1 meter deep. So what's happening here is we are putting water into the tank and it's filling up like this, right? So what they're telling us is they're telling us how quickly I'm pouring water into the tank, but our job is to figure out how fast will the height of that tank of water be going up. Okay? Now, what do you guys think is going to happen to the rate at which this water is rising as we go more and more? The rate will decrease. Why? Because as it goes up, it has to fill in more to go up higher, right? So when you start pouring water in, it's going to be really quick. It's going to be, and then after that, it's going to slow down and slow down and slow down. So the rate of change of the height is going to be slowing down over time. Okay, so there's that. Now, this is a little bit, once again, different. So just exposing you guys to some ideas here. So here's what's happening. What is changing is the amount of water in the tank, right? That's what's changing. And that creates a little miniature cone. And that little miniature cone also has a radius, but it's a changing radius, isn't it? As it goes up, it gets more, right? And it also has a height, but that's also a changing value, isn't it? Okay? Now these two shapes are similar to each other. And so what similar means is they're identical copies, it's just that one is smaller. And when that happens, they're proportional. So that means that the ratio of the radius to the height of this little one should be equal to what?
The ratio of the height.
There you go. It should be 3 over 9. They should be the same. That's a little trick right there I'm throwing at you. Similar triangles can come into play sometimes, or I guess in this case, similar cones. Okay, anyway, back to our regular process here. what is the rate that we're trying to find?
The increase in height of the tiny cone.
We're looking for the increase in how fast is the height of the tiny cone, the amount of water in the tank increasing. So that's going to be what? We're looking for dH dt, right? And that's going to be in what?
In meters.
Height?
Oh.
It's just meters, right, guys? Okay, so meters per minute. Okay, what rate did they give me, though?
The rate of volume increase.
Do you guys see that? It says water's being pumped into the tank. That's a volume, isn't it? Cubic? So that, what am I going to call that? dV. Good. So that's given. We have dV dt is equal to 2 meters cubed per minute. And that's going to be a positive value because we're increasing the amount of fluid in the tank, right? Okay, so I need a formula that connects the volume of a cone to the height of a cone. What would that be?
V equals 1/3 height times pi r.
There you go.
And we can replace the R with 1/3 H.
You got it. All right, so so now what variables do I care about in this problem? I only really care about height and volume. Which one do I not care about down here? Radius. It would be really nice if we could get rid of that somehow, right? And that's what this is all about over here. I can get rid of the R. Okay, so now what makes this problem harder, and I titled it, is that you have more than one variable here. And so when that happens, sometimes they give you extra information, and there's a way that you can substitute that variable for the one that you really care about. So follow me here. This is our formula, right? Now, first thing I'm going to do is I want to put the pi with the 3 just because they're both just constants. I just want to put those together. I'm just rearranging things a little bit. Yeah. Not yet. Not yet. I don't want to, so she said, wait, don't we do the derivative? And I'm saying, that's what makes this problem different. Not yet. Because I don't want to do that until I have really just the variables that I care about. Okay? So, now, which variable do I not care about here? I don't care about R. So it would sure be nice if I could find what R equals so that I don't have R anymore, right? Well, earlier in the problem, didn't we have this? What does R equal? I'm going to multiply both sides by H. And that reduces to, like Brody said a while ago, 1/3 H. Okay? So, do I have just V and H now? Now I've got a problem that's better. Okay? So, that's what, from here on out, there's really nothing different. I'll still finish the problem, but that's what I want you guys to get, is that sometimes if your formula has more than one variable in it, usually there's a way that you're going to have enough information to get rid of the one you don't want before you go any further. Sometimes they'll just say it'll be a constant number, so all you have to do is put a number in. Or in this case, it was a ratio, so we could replace it with the other variable instead. Anyway, no more yammering. That gives me pi over 3h, and that's going to be 1/9 h squared, which I can simplify some more into this. All right, from here on out, I think you guys will be able to handle it. I'm just going to zip through it, though. Take the derivative. Any questions about that one? What am I trying to find? I'm looking for this, so I need H and dVdt. Did they tell me any of these? Bless you. Did they give me H?
Yeah, 1 meter.
Yay! That's easy then. If you multiply both sides by the reciprocal, you get 18 over pi dH dt. And that is in meters per second. So that's a toughie one.
That's meters per minute.
Oh, was it minute? Thank you.
So slow that down.
What? Yeah?
Oh, I was going to say, why are you plugging that word?
Yeah, in the word problem they asked what is dH dt when the height is 1? And so that's why we put 1 in there. Okay. What do you guys think? We good? All right. So just for an experiment. Try that. We have a guy, and I'm going to represent him with a line, and he's 5 feet tall. Is his height going to change?
No.
How do you know? Maybe he just like had some milk, and he's going to like grow and okay. A 5-foot man is walking at a rate of 4 feet per second away from a light that's 20 feet. Is he walking away from it? So it's going to be behind him. And the light is 20. And the height of the lamp is not going to change either, right? Now this guy has a shadow, doesn't he? On the ground. And that's because the light's shining down on his head. Don't you agree?
Oh.
That is a hard picture to draw.
I got close to it.
Now, aren't these similar triangles, though? You guys can see that the little triangle is 1/4 of the size of the big one. So that might come in handy later. I don't know, maybe. All right. Find the rate at which the tip of his shadow is moving when he's 8 feet away from the lamp. Where would the 8 go? Now I'm going to put 8 here. I'm not supposed to though, right? Because really that's going to be a variable. That is changing. But I'm just going to put 8 here just so you guys know that that's the distance right from here to here. That's his distance from the light. But where's the tip of his shadow at? That's over here, right? What letter should we call that? Y? Sure, why not? Okay. So, I think that's good. I want you guys to come up with the next two things. What rate are we trying to find, and what rate is given to us? I'll give you a few seconds. Mm-hmm. I'm sorry, can't catch me up with you. I was say it all. Okay. So he is moving away at 4 feet per second. So what does the 4/20ths represent? Oh. Oh. So no. So what it is? This was a ratio of their lengths, right? Because that's the geometry, the shape of it. But when you're talking about rates, they may not have a ratio like that. So the rate is how fast it changes. But so what does have a ratio is that the ratio of this height is 1/4, or the ratio of y to the whole bottom is 1/4, or etc. But their rates, I don't think it's the same rates have the same ratio. But So what we're looking for though right now, you know how usually we start by saying that dx dt is what we can find, dy dt is what we're looking for. So that's what I'm trying to get you guys to do right now. Identify what rate did they give us and what rate are we trying to find. All right, so Max, what rate are we trying to find? Yeah. That one's that one's a little tricky. Did you get the rate that we're given? It is 4. So my question then it would be, what is the d stuff? D what? D what? That's true. I think this one's easy. Well, it's easier than the other one. The guy's moving at 4 feet per second. So don't you guys agree that x is increasing at a rate of 4 feet per second? So that's easy. I think the tip of the shadow is a little tricky, and I'll show you why. Yeah, Ryan? I was thinking that at first too, but I don't think so anymore. And here's why. This shadow is moving. Why is his shadow moving? There's 2 things that are affecting his shadow moving. That's true. The lamplight, right? And what else? He's moving. So here, check it out. Don't you guys agree that as you get farther away from this light, that the shadow grows? Doesn't it? That's why. Y is the length of your shadow. So as you get further away from that light, Y is growing. But that's not all that's causing the tip to move, right? What else is causing the tip to move? The guy's moving. Does that make sense? So you have the speed of the man, and you have the speed of the Y growing. So you have these 2 speeds working together. In other words, it's not just dy dt, but I think we need to create a new variable that I'm going to call d. It's how fast that bottom's changing, because that takes into consideration his movement and the shadow's growth all at once. Does that make sense? So I'm going to create a new variable there, and I'm going to say that we're looking for d dt. Mr. Bailey, how was I supposed to know this? You weren't. We're just exploring ideas. Opening your mind to new thoughts. All right. Now, do you guys agree that d equals x plus y? Okay. I need a formula that connects d to x. But I don't want y in there. Interesting. What are your guys' thoughts? I got to ponder too. So ponder for a minute. We need a formula that connects d to x, which this one kind of does do, but I don't like that y in there. Find y? Yeah? A ratio thing? Okay. So tell me a ratio. Close. 20, so they have to be matching sides. So 20 over d is equal to, can we get rid of the y now? Yeah. Okay, so the gals up here, I don't know if you guys are tracking, but they just kind of figured it out. They used ratios, right? 20 over d is equal to 5 over y, because those are similar triangles, right? Can we solve for y? Yes, you can. Yep, you can have d. We just don't want y. So let's get y by itself. How would I do that? Don't differentiate yet. No, not yet. No differentiating. I would just flip both sides over first. Is that okay? Why not, right? Multiply both sides by 5. Okay. See if you guys can take it home from there.
Could you simplify the
Why did I flip it? I want to get y by itself, and I thought it would be easier if we flipped it over.
Are you allowed to simplify the 5 to
Yeah. Yeah. So what does y equal, guys? D over 4. So come back over here to this. What am I going to write now for my formula? Do I have a formula now that connects d to x only? You can finish it, I think, at this point. Yeah. Oh, no, not necessarily. The reason why is because those aren't matching pieces. X is just this piece, right? But y is like the whole base of the triangle. The whole base is d. So we would match y to d, not y to x. Jennifer. Now we would differentiate. I don't know if you guys are interested, but bye. Yeah.
Can I still